In this video, we'll perform selection sort to sort numbers from smallest to largest using while and for loops. This video, the code in this video is from video C++ 57, where we explained insertion sort. So the code is pretty much the same. All of it will remain, except for this part is what's going to change. Instead of insertion sort, we are going to show how you could use selection sort instead. So temp and insert index will remain the same. Now the for loop is going to change. I would like to start looping from the first element until the second last element. And then minimum index. So what we're going to do is, I'll just show you an example, is say I've got those numbers, so 55, 88 minus 33. So we actually start from here and loop. So if the limit is actually, the limit over here is 7, so I'll just change that to 4. So it's going to loop until 3, but not including 3. So we're checking 0, 1, 2. And what we want to look for is the minimum index. I'm just going to rename. I might actually, sorry, I'll keep the, what have I done? Gosh, okay. So I'll keep this part here, that minimum index. I'll just put this down here. I'll change it later. I'll come back to these. So what we want to do is I'm gonna rename, I'm gonna declare this down at the bottom here. So we only need it down here. I'm gonna call this minimum index. So we need to assume that the minimum index is the first value. So the minimum index is equal to index. And then the insert index is going to be, we are now going to be checking. So this is, we assume this is the smallest value, because what selection does is you always look for the smallest element in each iteration. So in the first iteration, the minimum index is equal to 0. So we're looking at -2, this value. And then the insert index is just going to be the second value, which is, we're looking at indices here. So we're not looking at the value, we're looking at the index, so 0, 1, the location. Now while, so we only need, we'll do the checking the values later. So here is if it's less than the limit, we want to make sure that we haven't crossed over the limit. So this insert index will increase, but we would like it to stop to when it's less than limit. Okay, so that condition over here remains the same. I mean, like we've changed it. And now we want to check if, now we're looking at the value. This is our array. We are putting in these values into an array called numbers. Now we're looking at the value of insert index. So over here, we are saying if the value over here, 55, is, if we're checking if there's any smaller value, so if it's smaller than whatever's sitting in that, in the minimum index, so we assume is it smaller than what is in the minimum index. So over here, the minimum index we assumed was the first value initially, which we will update. So is this value smaller than -2? Is the value sitting at index 0, 1, sorry, is smaller than the value that is sitting at index 0, which was -2. So over here, this is actually false. It's not going to go in. But assuming that it's actually true, what we want to do here is I'm just going to close up my curly, my parenthesis. And then over here, we start a new bracket. If we find anything that's smaller, so let's just say we are comparing the value minus, let's just assume that we are up to that point. So here it's going to be true if this value is smaller than that, we found a value that is smaller than the first value. So in this case, what we want to do is we want to update the minimum index to the value, or this is to the insert index. So at that point, this would be 0, 1, 2, 3. So at that point, this would be 3. So the minimum index would now be 3. And then it's important that we increase, not decrease, because that was what we had for this insertion sort. And then once we've, like for this one, we've actually, assuming that we found a smaller value, we finished from iteration. Before we go to the next index, while we're still in the first iteration of this loop, now we want to do a swap. We want to swap this to be in here. So what we're looking at is minus 33 instead of, and then that goes to minus 2. So to do that, what we want to do is we want to put the value that is at minimum index, which was 33, minus 33 at that point. So that's what we did here. And then whatever's sitting at minimum index 3 is equal to the numbers we would like to access the value that's here originally. So minus, just bringing things back. So we want at minimum index, so at that index, we would like to have the value that's sitting here. So which was index. So up to this point, what we did is we've put the value minus 2 in here. But we have a record of temp. That's why we have this temp. This is important, because otherwise, if we don't do this line, we've lost the value, the smallest value, which was 33, because we've overwritten or we've replaced things there. And then at that index, 0, this is going to be equal to the value that is sitting in temp. So what happens is 33. Okay, I'm going to do this again, but I just want to check that my code actually works correctly, and then I'll run it all over again. What might also help is to actually print out the content. So let's just see how this works. Oh, I've got an issue there. I've forgotten to, I'm not sure where that came from, but okay, so it was, we have minus 2, 55, 88. I'll just try to stick to these numbers so we can, so after the sort, it's minus, so the sort is working correctly. What would be worth doing is to actually print out the array. This is just for debugging purposes. It's not something you want to do in your actual, unless that's what's needed. So inside the sort. Now, index, we don't want to override or change the value of index, because otherwise we will lose that. So I'm going to create, I'm just going to call it index 2. It's not perfect. That's not a good name, but for now it should be all right for now. And yeah, so let's just see what this will give us. Okay, that looks bad, but so initially we've swapped minus the first iteration, the smallest elements. And actually, you know what will help is to print out. Now there's a lot of code duplication going on there, but it's good to actually print out what it looked like previously. So I could use index here again. Okay, and I'd like some info. So here, original list, and let's just print out a new line. I could put this into a function and just call it whenever I want to, but it's not the topic of today, so I'll just it's -2, 55, 88, -33. So what's happening here, this is our original list. We assume this is how selection sort really works. I'll explain it. So we assume that the first value is the smallest value. And then what we do is we iterate through the rest of the list to look for a smaller value. So because our list over here is iterating to the second last, but we've got that insert index is adding 1 to the index. So that will give us access to the last value as well. So in the first iteration, we have done we actually found the smallest value in the list. So we can now assume this part is sorted. This is the smallest value that we found from this part. So here we assume this was the smallest, and we checked a smaller value in the rest of the list, which we found was 33. So we've taken that. At this point, this part is already sorted. Now what we do is we will keep checking for another smallest value, which in this case was -2. And then after that, so that was swapped with 55 because we are checking the second index against the rest of the list. And then what we do is we'll check the third index, sorry, the 0, 1, 2, which is the third value in the list against the rest of the list, which was 55. And the swap happens. And so after the sort, just prints out whatever the list looks like after the sort. So let's try to look at what is happening over here. So the first index is 0. We assume that's the smallest value. And then we want to look at the list starting from the second value. Now, while 1 is less than 4, this is true. So we will go inside our loop. Let's see what this translates to. Now the value in the insert index is, so insert index is 1, so the value is 55. So here we're saying is 55 less than whatever's sitting at minimum index, which is 0. That was -2. That's false. So we will go all the way here, and we increment this, so this becomes 2. Is 2 less than 4? True, we'll go inside. And at this point, we'll say, okay, let's look at 0, 1, 2. Is 88 smaller than -2? False. False again. We'll go inside. This doesn't happen, but we'll still increment that to 3. Is 3 less than 4? Yes, it is. We'll go inside the loop one more time. And now we'll check, is the third value, so 0, 1, 2, 3, this value, -33, is less than -2. In this case, yes, it was. It's true. So what we'll do is we'll go and update that minimum index. It now becomes equal to insert index, which was 3. So now we know that the minimum index, or the minimum value, sits at that third index. So this should be 3, not 33. Okay, so now we know that the smallest value in the list is sitting at index 3. 0, 1, 2, 3. So now this part, this becomes 4. This becomes false. Where am I? So this becomes false. We step out, but we've got our info. That's what we need. At this point, we say temp is equal to, now we want to get the smallest, we want the value at the minimum index. So that'll be -33. And then we just basically want to perform a swap. And then we say, at this index, take the replace the value that's sitting at index 0. So index is actually equal to 0 at this point. So here what we say, whatever is sitting here will actually have the value that's sitting at index 0. So now we have -2. We've lost any value of 33, but luckily we've got it preserved in temp. Okay, and then here we'll say, okay, and then the value that is at index, this value, now becomes temp, which is 33. So at printing this one, we basically have this printed in the first iteration. In the second iteration, now this part is already sorted, we're not looking at that. Now index is equal to 1. And now we'll be repeating the same process. We're looking at the minimum index. The minimum index was actually updated is equal to 3. So now we are checking if there's anything smaller than this value in the remaining list. And the same process repeats. So what happens is at that stage we've found that -2 is smaller than 55. So we will have the list looking like this. And then when index is equal to 2, now we're basically just looking at the smallest value. So we find that we're looking at 88 and 55. So at that point, 55 is smaller than 88, so a swap is performed. So that's pretty much it. And if we were to test this with any, let me just change this limit to say back to whatever, 7. I can put in more numbers. So let's just say -2, 55. I'll have something smaller, -100. Oh, sorry, I put 44 before. 2000. So we look at the last one. So we've got -100, -15. So this is sorting in ascending order. And that's pretty much how selection sort works in C++. I hope it was helpful, and I'll see you in the next one.